All right, welcome to Unit 2, Module 4. We're going to be continuing our talk about Linux here. So today we're going to be talking about, some of the history of Linux and some of the distributions, what a distribution is. Also be talking about the Linux file structure. We've touched on some of the basic commands for Linux, how to navigate through the file system. I'm going to talk about some of the important directories in Linux here. And then we'll go over some more Linux commands that'll be useful. And then we'll learn how to update your system. This is very crucial for staying secure. And then we'll go into a little bit about sudo and what exactly that is. A lot of people pronounce this sudo or sudo. Doesn't really matter. I think the correct way is sudo, but I've gotten in a bad habit and just been saying sudo. Okay, so why is Linux so important? So Linux is run on a ton of machines out there. If you were to take the top 1 million websites, over 95% of them are going to be running Linux. And then just in general, different servers out there, they're going to be running about 70% of servers out there are running some form of Linux. The rest are going to be running Windows or OpenBSD, different things like that. So Linux is very important. If you're a system administrator, you need to know how to manage a Linux system. If you're a pen tester, you need to know how to break into Linux systems, how to harden them, how to test them. If you're a blue teamer, same concepts. So who needs to know Linux? We talked a little bit about this, but sysadmins, pen testers, if you want to get into network forensics or just Linux forensics, computer forensics in general, you'll have to know Linux, how it works, how the file structure is, and where different files are stored. Depending on your job, possibly in help desk, and also blue teamers. Okay, so different distributions of Linux. So what is a distribution in Linux? Essentially, it's just a different flavor of Linux. There are so many different types, and so different flavors or different versions or distributions are going to serve different purposes depending on what your needs are. So on the slide, you'll notice there are 6. There are hundreds and hundreds out there. So CentOS, we've got Fedora, Ubuntu, Debian, Linux Mint, Kali. They all have their pros and cons. So there's no one solution that fits all. If you look at this slide here, you don't have to know this, but it just kind of gives an idea of where different distributions of Linux come from. So they all kind of stem from this base Linux or Unix base operating system. And a lot of the more popular ones are going to be in this Debian branch here. And from Debian, which is kind of a bare bones version of Linux, if you come over here, you're going to notice Ubuntu is on the top right of the screen there. Ubuntu is probably one of the more common ones for everyday use. And so it's a very common one for web servers, just everyday desktop management, things like that. The two that we're going to be focusing on the most in this course, these are going to be Ubuntu and Kali. So Ubuntu is going to be your everyday Linux usage, and then Kali is actually going to be a special distribution of Linux that we're going to be using for pen testing. So both of these, hand in hand, we're going to be coming across these quite a bit. Generally, if you're coming across a box in the wild, it might be an Ubuntu machine or it might be a Debian machine. There are a lot of CentOS machines out there as well. Red Hat is another popular one. I'm not going to get into the details. The most important thing that you need to know is that there are multiple versions out there. I recommend you go and look up different versions that you're interested in and learn a little bit about those. But for the sake of this course, this is all you need to know. We're going to focus on these two. So let's actually jump into the Linux file system. So where are different files stored on the system? If you'll notice this first one, this is root. That's just a slash. I put parentheses around root just because it doesn't have an actual name in the file system. It's just called the root directory. So it's the beginning of the file system. If you were on a Windows machine, this would essentially just be the C drive, and you go all the way back and you can't go up any farther. So the root directory holds all files on Linux. You can't go up any higher than that. The home directory is going to contain all of the users' home directories. So let's say you add a Max user, a Bob user, a Sally user. Each of those are going to have their own home directory. Now, if you use Windows or Mac, you also have a home directory, and all of your files are stored in your home directory. The desktop, documents, and like your music, your pictures folder, those are all stored in your personal home directory. So each user has their own home directory, and they only have permissions to view their own files in their own home directories. And now we've got another directory called etc, etc. A lot of people pronounce it Etsy. So this houses all system-wide configuration files. If you make a change in one of these files, the settings and configurations here are going to be system-wide changes. So they apply to all users. It's not a per user change. These are for everybody. And now we've got the var directory. This is short for variable. Files that are constantly changing are going to be stored in here. The best example I can give right here are log files. Log files keep track of when people log on, when things are deleted, when users are created. Those files are always being added to and being changed. And so they are variable, so log files are stored in the var folder. And then we've got the temp folder, files that do not persist across reboots. If you were to put a file in the temp folder, tmp, and you rebooted the machine, it would be gone. Now, why would you need a temp folder? A lot of programs install, they need a place to put temporary installation files, so they put them here. A lot of pen testers or hackers, they'll put their malicious scripts in the temp folder. The reason is everyone can write to the temp folder. It's a good place to store things temporarily if you're not sure where to put them. And then we've got the boot directory. Do not touch anything in this. I'm just putting it here so in case you come across it, you'll have an idea of what it is. All the files that are necessary for booting up Linux when you start up your machine, the files in here are going to be accessed. And we've got bin and sbin. These are short for binaries. So these are programs that the user can run. We've gone over things like cat, nano, ls, man, word count, things like that. All those user programs or that come built in with Linux are going to be in generally one of those directories. Now, a lot of you might know the basic parts of a computer. For those that don't, I'm going to touch on it real quick. So memory, or RAM, which stands for random access memory, you may have heard this term. Oh, you just need more RAM. Like, your programs are running slow, so people say you should buy more RAM. So anything that is running on your computer right now, if there's a window open or if there's a process, it's going to be running in random access memory. If you were to pull the plug on your computer or to shut it down, the contents in RAM would not be saved. So let's say you're typing a Word document or you're making a file and you're typing into the file. If you haven't saved the file, right now the contents of what you're doing are running in random access memory. If you were to pull the plug on the computer, it would not be stored. It's volatile memory. Now, long-term storage or disk storage contains files that are persistent. So these are things that you control save. You save it to your desktop. You actually put a file name on it. If you shut off the computer and you turn it back on, the file should be there. So these are generally stored on a hard drive or a solid state drive. And then we've got the CPU, the central processing unit. This handles all the decisions and processes on the computer. All the ones and zeros go through this, does all the math, computational things. Lots of complicated things in there, but it's kind of like the brains of the machine. It makes all the decisions. When you click on something, the CPU says, hey, do this, do that, open this, and it sends commands everywhere. And the networking card just helps you connect to your Wi-Fi or your Ethernet or your internet. And then your graphics card. Some computers have it, some don't, like a dedicated graphics card. So a lot of people will install a dedicated graphics card so they can do film editing, Photoshop, heavy gaming. So it helps you process heavy graphics. So enough on computer parts. Let's get into Linux management here. So before I get into the Linux management, let's actually go over the file system here. I kind of jumped the gun here. Let's log into the machine here. Okay, so remember, if I type in pwd, this is going to be print working directory. This shows I am in home Cybertrack. If I do ls, shows documents, downloads, pictures, public tools, videos, etc. And then I can also make a desktop folder if I wanted. But I'm going to do clear. And if I do cd space root directory, so if I just put a slash, notice here, if I type in pwd, it's going to show root directory. So if I do ls here, this shows all of the files and directories in the root directory. Now the ones that we talked about, etc, home, bin, sbin, things like that, those are some of the more common and important directories that you should know about. You don't need to know everything right now, but I think that those are going to contain about 90% of the work you'll do in Linux. So anything outside of that, you'll come across, but I can go over it real quick in another lesson as well. So we talked about the home directory stores all the users' home directories. etc contains all the configuration files. And then mount and media, those are if you wanted to plug in like a USB or something like that. And we've got root. This is actually an interesting directory. So it's different than the root directory. So this is actually the root home folder. So the path would not be root directory, it would be root directory root. Files stored in here are files that belong to the user root, which we will talk about. Root is the highest privileged user on the system. We will get into great detail with this later. For now, just know it's the home directory for root. Then we've got sbin, contains all those binaries, programs like ls, man, same with bin. Then we've got the var directory. So this is where a lot of the log files are going to be stored. So if I go into cd var, and I do ls, you'll notice there are backups, cache files, library files, log, mail. These are files that are constantly changing. So one of the most common places in the var directory is var log. So I would say if you were to pick a couple places to remember, I would say definitely remember the etc directory, remember the home directory, and the var directory. There are other important files within the Linux file system. I'd say start with those for now and feel comfortable with what those mean, where they are, etc, var, and home. Okay, and then sbin and bin as well. And then if we were to go into the root directory, then we did ls again, and we did cd bin. If I did ls, you'll notice there are a lot of programs here. You may recognize some of these. So ls is here. We've got sed. We've got pwd. We're going to be going over ps later, which I think we use that a little bit. So there are a lot of different programs in here. If I go into root directory sbin and do ls, there are even more programs. Some of these we may have covered, some we may not have. But a lot of the programs that we run on Linux, just in the command line, are in these directories, bin and sbin. So I'm going to do clear. Shortcut, if you ever want to get to your home directory, you can just type in cd, enter, and I do pwd. Now I'm back home. When you log into your MacBook or your Windows machine, you don't really see this because it's not a command line operating system. It's not focused on that. But you are technically in your home desktop directory, like your home, your username, and desktop. So you are starting from your home directory using a graphical user interface. Linux just does it in the command line. So every time you open up your terminal, it's going to default to your home directory. Remember, pwd shows you your home. All right, enough about the Linux file system. I hope that was pretty helpful if you've been wondering where certain files are. Now let's get into Linux management. So these commands here is going to be top, ps, and kill. Top is a good program. It shows you different resources, different parts of the system that are being used, all the resources. And then we've got ps, which is going to give you running processes. It's going to take a snapshot, so it doesn't update constantly. Top, on the other hand, will update every 3 seconds. And then we have a program called kill. So if we can find the process ID, so a unique number tied to a certain process, we can actually kill it. So let's say Google Chrome was giving us problems. We could actually find the process ID for Chrome, and we could type in kill and then whatever number it was. So if the process ID for Chrome was 2001, we could do kill space 2001. Okay, let's do an example here. So if I type in top, you'll notice you get a lot of information here. Up here is going to show how much memory or random access memory I have and how much is available, how much is free. This shows me how much is used. And then there are different things up here. So let's see, percent of CPU being used, give you some details about the CPU. And then it shows you how many processes are running. And then up here, we've got information about running processes. So here on the left, we've got process ID. And then we've got the user that is running the process. So in this case, we've got the Cybertruck user is running a certain process, top, which is the one that we just ran. And then we've got some other information we're not going to get into, but it also shows like CPU usage, RAM or memory usage, and the actual command that was used to start up the program. To get out of top, you can actually do Control-C, or you can hit Q. I'm going to do Q. You can clear your screen with clear. So we talked about processes. Let's actually do something here. So I'm going to split the screen here. Control-L. I'm going to do a new terminal window. So let's drag this over here. I just want to show you how to kill a process. So I'm going to use a program called ping. You don't have to know what that is now. We're going to get into that a little bit later in our networking section. I'm just going to be pinging a certain IP address just to test my network connection, and it's going to be doing its thing. Now what I can do here is actually type in top. And if I expand this window just a little bit, I can get some more information here. And it'll update every once in a while. We might not be able to see it here, so I'm going to do Q, which brings us to the next program. So PS is a program. If I type in PS, it shows different processes that are running right now. If I want to run or get more details and run all the processes or see all the processes that are being run, I can actually do this. So you'll notice we've got this process right here, ping 8.8.8.8. And if so that's what's running here on the right side. And I can see the process ID here, which is 4309. So if I type in kill 4309, it may or may not work. Let's try it out. Operation not permitted. We actually need higher privileges in order to run this. So for now, I'm going to run this program called sudo in front of it, which is going to allow us to run this with higher privileges. We will get into this in more detail later. But for now, just know it allows us to run it as a higher privilege user. So I'll type in the password. And notice here on the right, it says terminated. So this process was terminated because we typed in kill and the process ID. If we want to stop a process, we need to use something called sudo. We'll get into that later. For now, just know what top, PS, aux, and kill do. Generally, you're not going to be running PS just by itself. You're going to be running it with the different flags here. So if you want to get more details on the PS program, you can always type in man PS. And for different options, if you look here, note that PS aux is distinct from PS aux. Give some more information about what all these different flags do. You can do some reading. Also, we've got some good examples. So to see every process on the system, you can run this PS AUX. I'm just used to writing AUX instead of AXU. It's the same thing, doesn't matter what the order is, but PS is the actual program. These are the options or flags. Okay, so now we've gone over different processes. Next thing I want to go over is updating our system. There are a couple things here. So let me pull up the slide. So if we want to update our system, we would run something called apt-get update. We could also run just apt space update, which is short for apt-get. If we wanted to upgrade the system, we would type in apt-get upgrade, and this upgrades packages to newer versions. So if you had a version of Python or Nano that was outdated, we could get the latest version. So if there's a major package release, we could get the latest. Now, if we want to install a new package that we don't have on the system, we would type in apt-get install and then the name of the package. And in order to remove a package, we would do the same thing, apt-get space, remove, and the name of the package we want to remove. Now, all of these commands must be run with sudo or elevated privileges. Let me give an example here. Okay, let me just make sure I don't have this installed already. So which, Calce is just a program here. So in order to delete a program, let's just double which nmap. All right, so I'm actually going to remove a program and then I'm going to reinstall it. Let's go ahead and do this. So sudo, we have to run this with elevated privileges, and I'm going to close that out. Sudo apt-get remove and the name of our program. So Calce, and it's going to prompt us, do you want to continue? You can hit Y for yes, N for no, and then enter. This will take just a second. We can do clear if we want. And now what I want to do is install the program. So I can do sudo apt-get install Calce. So now Calce is not on the Linux file system. I can actually install it now. It's going to prompt me, possibly. Okay, and so it just reinstalled it. Essentially, we removed it and then added it back on. A lot of the times there are certain programs that don't come with Linux, and so let's say our program Nano for text editing, which we'll be using. If you wanted to install that on the system, you would have to do sudo apt-get install Nano. Now it comes default on a lot of Linux file systems, so you may not have to install it. If you want to test this out on your own machine, feel free to run this program sudo apt-get install nmap. Nmap is a network scanner, which we'll be using in the pen testing section and networking sections. So you can run this, install it just for practice here. I already have it installed, so I'm not going to run it. Okay, if we want to update the Linux file system, we can do sudo apt-get update, enter, and it's going to look through some different sources, and it's going to ask you, do you want to upgrade or update? You can push yes. If there are no changes, it's going to look something like this. The next thing we want to do is type in sudo apt-get upgrade. Sometimes I'll run the upgrade first and then the update just to be sure. So it's going to ask us, it's going to use 41.3 megabytes of additional space. Do you want to continue? I'm just going to do yes. So it's going to go through, find different programs, packages, install them to your computer, and give you a little bit of like a percentage down here. And then it's going to show you how fast it's downloading the files here on the right. Now it's going to extract it, it's going to install it, it's doing its thing in the background, so you don't really have to do anything. So now you know how to remove packages, install packages, upgrade the system, and update the system. For the next class, we're going to be continuing Linux. We're going to get into more permissions, and we're going to talk about elevated users. We're going to talk about adding users and groups to a system. This is going to be important for system administration. So stay tuned. We're going to get started on that in the next class, and hope you enjoy this. Thanks.